Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So let's move to the second part of opamp. So what you're going to learn for this part is ideal characteristic of the opamp, golden rule, how you're going to design the opamp, and why we need negative feedback. So what is actually the ideal opamp characteristic? So when we are talking about ideal, is a perfect condition of the opamp characteristics. So the ideal characteristic of the opamp is the first one, R in, the input resistance is equal to infinite. Second one is your R out is equal to 0 and your open loop voltage gain is infinite. So the first characteristic is your input is equal to infinite, your output will be equal to 0, and your gain, open loop voltage gain, will be infinite. So I will explain further why we get this AB infinite and why the R in and R out is infinite and R out is infinite. So in order to understand why we have this infinite, 0, and infinite, so let's go through the golden rule to design opamp first. So in order for you to design the opamp, what does it mean by design? So design means you need to find the value of the resistor at the opamp. So you have two rules here. Okay, the first rule is the voltage difference between the input is 0. So what does that mean here? How many input voltage connected to the opamp? So we have what we call inverting, another one is called non-inverting. So we have two voltage here, one is V1 and one is V2. So it's saying here voltage difference between the input is 0. So means your V1 minus V2 will be 0. So what does that mean here? Your V1 need to be always the same with your V2. So that is the first rule. The opamp try to make the input voltage the same. So let's say I apply here 5 volt. According to the rule of the opamp, your V1 also will be 5 volt. If I change this to 10 volt, your V1 will be also 10 volt. So that is rule number 1. The opamp try to make the input voltage the same according to the voltage determined by V2. Second golden rule, no current flows into each or out of each input. So what does that mean here? So that means that there will be no current flowing inside the opamp. So the current here will be 0 and the current here also will be 0. So that will be rule number 2. Rule number 1 we call voltage rule. Rule number 2 we call current rule. Rule number 1 says your V1 and V2 will be the same. And rule number 2 says there will be no current flowing inside the opamp. Okay. In order to explain the ideal characteristic as I showed you previously, this one. So how are you going to explain this one? Open loop voltage gain is infinite. So in this case, we can use rule number 1. So first, you need to verify how we can get AV is equal to infinite. So based on rule number 1, it say here, so this is, let's say this is V1 and this is V2, right? V1 and V2. How you find the gain? Gain is equal out over in. So this is actually V out divided by V1 minus V2. But based on golden rule number 1, that golden rule number 1 saying voltage rule, where you need to make sure your voltage will be the same. So let's say I apply here 5, here we also will be 5. So when V out divided by 0, there will be no difference, right? So your AV will be infinite. So that's reflect the characteristic of the ideal opamp, that is the open loop voltage gain will be infinite based on the golden rule number 1. Okay. So the open loop voltage gain will be very high due to the voltage at the input will be always the same. Okay, let's move to characteristic number 2. So just now we verified the characteristic of AV must be infinite. How we can get Rin also infinite? So this will be based on the golden rule current, the current golden rule. So current golden rule says there will be no current flowing into the op-amp. So this one will be 0. I here will be 0. So since we want the Rin to be infinite here, so you know R equal to V, Rin equal V in over I in, right? So this here will be V in over 0. So will be 1 over 0 will be infinite. So that's why we can get the second characteristic of the ideal op-amp, Rin will be infinite. So as the summary here, how you can get the ideal characteristic of the op-amp. So you know your AV here will be infinite, your input resistance will be infinite too, and your output resistance will be 0. So how we can verify this one, AV equal infinite, from golden rule number 1 saying that you are trying to make the input voltage the same. Input voltage the same. Okay, how we can get Rin is equal to finite from golden rule number 2 where there will be no current flowing inside the op-amp. So here will be always 0. Okay, in the real cases, if you see the range of the open loop voltage gain is very high, around 10 power of 5 to 10 power of 8. Your input resistance also will be very high. Your output resistance will be very small. Okay, the last one, why we need this supply voltage? Because your op-amp is an active device, so we need a DC supply to turn on. So in this op-amp case, we need both supply, either V plus and V minus, and the range of the supply needed is between 5 to 30 volt. So as we can see here, your gain here is very high, right? So let's say I apply small input here and it go through the op-amp. But if the gain is infinite here, will you get a proper output at this output voltage? So I believe there will be some we cannot get the gain here, right? Because of the gain, open loop voltage gain is very high. Okay, what does that mean? Means that your open loop voltage gain, this is open loop voltage gain is infinite. Your Rin will be infinite. Your Rout will be 0. What are these characteristics? This one is the ideal characteristic of the op-amp. If we apply this in the real case, you are going to apply a small voltage. What you need after the op-amp is you need a defined output. Means let's say here you apply 1 millivolt. You need to amplify either 5 volt. Can you do this with the open loop voltage gain? No, right? Because here is infinite. You cannot have a finite number at the output here. So that's why this one plays important role, what we call here feedback. So what will feedback do? Feedback will add, this is your V1, V2. So what will feedback do? Feedback will add some element here connected from the output to the input. So this is what we call feedback. So what is the role of this feedback is to control the gain. So we can control here. Let's say your input is 1 millivolt, your output is 5 volt. So how you can calculate your gain is actually output over input, right? So it becomes 5 divided by 1 millivolt. So how you can control this gain? By adding a feedback. So is it need to be positive or negative? So it need to be negative feedback. So where your feedback must be connected to the inverting input instead of non-inverting input. So we need feedback to control the gain. Okay, let's say this is one of the example of the feedback circuit. So when you want to design the op-amp, you need to apply to the golden rule. What is the golden rule number 1? Voltage must be the same at your input. So let's say here you apply 6 volt here. Applying golden rule number 1 here also will be 6 volt. Why? Because golden rule number 1 says there will be no difference between the both input voltage. So there is a feedback line here. So this is what we call feedback. So after the feedback, you will receive here 6 volt. 6 volt. So what will be the gain of this amplifier is output over input, means 6 divided by 6 equal to 1. So whatever you got here at the input 6, it will be received at the output of 6 volt. So this is what we call negative feedback. Negative feedback. So in order for you to change the gain, you need to apply some element, either RL or C, at the feedback circuit. So in order to, let's say we apply resistor, then we can control the value of your gain. Okay.